Hey everyone, okay, so today's video is going to be about a new article I just pulled up this afternoon and started reading, and it has to do with the Arctic sea ice. And that is that the extraordinarily melting of sea ice in the Arctic this summer has shattered the all-time low sea ice extent record set in September in 2007. 2007 was a very low year for sea ice in the Arctic, and that was the last time there was a recorded all-time low. And because of all the warmth this summer, we now have an all-time low. And the sea ice continues to decline far below what it has ever been recorded. I mean, observed, not recorded, observed. And I'm reading off notes that I pulled off of the internet and stuff, so you can find this off Wonderground. This is where I found the article and stuff. So I just want to give you a couple interesting details and all that stuff. Pretty much half of the sea ice extent for this year is at half, 50% of the median between 1979 and 2000. So pretty much the average between 1979 and 2000, the sea ice right now is 50% of what it was between 79 and 2000. So it's 50% gone, and it's just extraordinary. And I was reading the article and I'm like, oh my gosh, wow, that's a lot of ice just gone, just melted. So there's obviously something's going on here, right? Yeah. So kept reading and stuff, and I also found some average monthly ice extent, a graph and stuff, and it just shows how the ice is declined in kilometers and stuff from when we started beginning taking observations of the Arctic sea ice in 79 till right now. And when we started taking observations in 1979, it was about a little over between 8 and 8.5 million square kilometers of sea ice. And right now, the new report came out, and it's right around 4.6, 4.7. So again, that's about half of it all gone since we started making observations on the Arctic sea ice and stuff. So I found that very, very interesting. Also, just recently, this past week, Alaska has dealt with a huge, massive storm. They're saying it's 1 in 100th year storm and stuff. You know how rare big storms can be, and apparently this Alaskan storm is one of those rare events that happens only once every 100 years and stuff. And just a couple reported wind gusts in Alaska. McHugh Creek, I don't know exactly where these are in Alaska, but I know they were reported in Alaska. But McHugh Creek in Alaska recorded 88 mile per hour winds. Paradise Valley recorded 75 mile per hour winds. Upper Hillside, which is about 1,400 feet, it's on a kind of, not the edge of a mountain, but it's on a higher point than most locations that observed wind, 1,400 feet, and that they recorded a 70 mile per hour wind. And Anchorage Port, which is on the southern end of Alaska, obviously on the Gulf of Alaska, near the water, recorded 63 mile per hour winds and stuff. And the storm itself, I have it right here, weakened, well, not weakened, but had a very low central pressure of 970 millibars, which is very, very low for a land storm and stuff. And if you compare that, it's to a category 1, maybe category 2 hurricane. So it's actually a significant storm, and it just pummeled Alaska and northern Canada this during the past week and stuff. And one of the reasons why I bring that up is because of the decline in sea ice, because there's more moisture, there's more water, you can actually get more storms to develop and stuff. And this all has to do with climate change and where we're going into the future and stuff. So I have an article right here pretty much saying that stronger storms due to more moisture content in the atmosphere and more open water and warmer conditions in the Arctic could lead to more storms like the one that Alaska and northern Canada just saw over the past week and stuff. So just kind of something to look out for and all that stuff. The fact that the Arctic is warming, the fact that the sea ice is at an all-time record low, like, ever, like I mentioned earlier, since records began and stuff in 79, and just the fact that, with the melting of the sea ice, obviously that helps with increasing in sea level waters. So, and that's all around the world, obviously. So it's just something to like look out for, and it kind of just like caught my eye when I was reading the article and everything. And it's kind of like a double whammy, sort of say, because there's melting of sea ice, which rises, sea levels up, but then, obviously that could affect people in, Alaska and northern Canada because of the fact with more moisture and all that stuff in the warmer waters and stuff, and just the fact that there is more now open water than there ever has been in the Arctic, you can get more storms because, like hurricanes, you have the water, you have the warm water, you have lots of water to deal with and stuff, and you just have the right atmospheric conditions and you can get storms. Same thing in the Arctic and stuff, just they're not hurricanes or tropical cyclones, obviously, but storms do stir up and stuff. And one of the reasons why storms actually happen is to pretty much balance out the temperature between like hot and cold. So that's why whenever you have like really hot days and then all of a sudden like a cold front comes through, it's usually associated with a storm, because all the storm is doing is it's transferring like the heat to like balance everything out throughout, like equilibrium pretty much. It's bringing everything, or trying to bring temperature to like an equilibrium, which is why we have storms throughout the world and stuff. And having more water and warmer conditions coming into the Arctic gives the Arctic more chance of actually like creating storms, because you have a lot more warmth, and obviously, like the cold needs to go somewhere, and so the cold, wraps around and stuff and all this other like atmospheric stuff, and you get a storm out of it. And there's a ton of more factors and stuff, and you get a storm, and it just like, obviously creates, wind and rain and, snow and everything, but the main reason for storms is to pretty much equalize pretty much the temperatures throughout the whole entire world back into like their, regular sections and stuff, and it also depends on like the season, the time of the season and stuff. So I just found that very interesting to find this afternoon, about the sea ice and the fact that, like more storms are possible in the near future, or, just down the road due to just melting of the sea ice. And sea ice is very important because they, like I said, they help regulate global temperature by reflecting the sunlight back into space. That's what I wanted to say earlier. That's the, main reason why sea ice is important, is to regulate the global temperatures and reflect the sunlight back into space and stuff. And so while the snow and ice poles reflect sunlight, dark ocean absorbs it and stuff. And so replacing bright sea ice with dark ocean is a recipe for more global warming, sort of say. And I actually have some of it written down here, so that's why I'm like looking down. And I also have that cooler air over the Arctic has increased by about like 4 to 6 degrees in the past decade. Actually, no, not cooler air, but the air in the fall and stuff has increased. So it's been a bit warmer in the past decade for the fall months over the Arctic and stuff. And you could be seeing like the impacts of the warming, obviously in the mid-latitudes. Obviously this past summer has been extremely hot in the mid-latitudes, which is where the United States is. And obviously last summer and the summer before were very hot and stuff. And with all of this, you can see an increase in extreme weather events, which has to do with like storms in itself. So pretty much just the fact that the Earth is warming, creating all this sea ice to melt, gives way to pretty much just more violent weather. If that's where I'm going with any of this, that's where I'm going. Just more violent weather. Just something to look out for, and, people have asked, can we do something about this? Is there a chance to go back? Blah, blah, blah. And just, like be earth friendly, be green, help out, recycle and everything. Every little bit helps, obviously. And we don't want to live in a world that's like, 100 degrees every single day, and be threatened by like all these like natural disasters and everything. So sea ice is important, and, even though a warming earth, can be beneficial in some ways, not having like the cold air and the sea ice, and just not having that balance between cold and warm can be an issue, and stuff. So I just wanted to mention a couple things on the sea ice and how like little there is pretty much. I'm looking at a picture right now that I downloaded off of Wonderground, and you can actually go to Wonderground. It's then underground.com and stuff, and they have like all these like cool articles and stuff, and I just pulled this one off this afternoon before dinner and everything, and I just wanted to share it with you. And this picture, it's like there's like white obviously represents ice, and there's like just like a little circle, kind of, not circle, but it's like a blob, not blog, a blob of ice, and it just is like, oh my god, it's like nothing and stuff. Like Greenland's pretty much like ice free, it looks like. Like even like there's no ice in the Hudson Bay or like northern, provinces of Canada. Pretty much it's just like right around the North Pole, and that's it. So I found that very interesting and stuff. And that picture was taken as of yesterday, so that was September 5th, 2012. So that is my video for the day and stuff. Just another interesting article to talk about. I will be back hopefully with an update on Hurricane Leslie, or Leslie, I can't even pronounce the name, but I'll be back with a tropical update in the next couple days. Until then, remember to keep your eye to the sky.